In question number 2, we're given a differential equation, 2 minus t times dy dt, minus y equals tangent of t, an initial condition, y of 3 equals 0, but unlike in question 1, our goal here is not to solve the differential equation. Instead, we want to give the interval of definition of the solution of the initial value problem. Now, this is a linear differential equation, which is good, because if this was a nonlinear equation, as we discussed in class, there's a lot more work involved to finding the interval of definition there. In fact, for a nonlinear equation, you can't find the interval of definition without actually solving the equation. So the fact that it's linear really ties into the fact that we're being asked to do this without solving the ODE. What we do need to make sure we do is that we put the differential equation in the standard form for a linear ODE first, which means we want the coefficient of dy dt to be 1. So, first of all then, we're going to write this equation not in its given form. So we're going to divide through by 2 minus t. So we're going to write this as dy dt minus 1 over 2 minus t times y equals tangent of t divided by 2 minus t. So that the functions of t involved in this equation, first of all, the coefficient of y, what I call p of t, is negative 1 over 2 minus t, or we can simplify that to simply 1 over t minus 2. That's not essential, but it'll make writing this a little bit easier. And the non-homogeneous function g of t, which is the tangent of t divided by 2 minus t. And we need to figure out, well, where are these two functions discontinuous? In the case of p of t, that's pretty easy. It's a rational function, 1 over t minus 2, which means it's only discontinuous when its denominator is 0. So if t minus 2 is 0, then t is 2. In the case of g of t, that's not a rational function, although it does have a rational component. And we can see again, when t is equal to 2, we get division by 0, which would mean that it's also a discontinuity of g of t. But because we've got that tangent function, tangent is not a continuous function for all real numbers. In fact, specifically, it's discontinuous at plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. So in fact, any odd multiple of pi over 2. So it's discontinuous at t equals 2 and t equal to, let's say, k times pi over 2 for odd k. So I found that the easiest thing to do now is to map out those discontinuities on a number line for t. So t equals 2, let's put that down. The odd multiples of pi over 2, well, pi over 2 itself is 1.6, give or take. So in particular, it's less than 2. 3 pi over 2 is 1.5 times pi, so it's 4 point something, so it's bigger than 2. And then we can easily fill in the other discontinuities from there. And of course, there's an infinite number of them, so I won't put all of them in, since that would not be possible. But I'll put down enough so that I've got a sense of where they all are. In particular, what I'm looking for is which of these now possible intervals of definition. So, for instance, one possible interval of definition is negative 3 pi over 2 to negative pi over 2. One is negative pi over 2 to positive pi over 2. Positive pi over 2 to 2. 2 to 3 pi over 2. 3 pi over 2 to 5 pi over 2. And so on. I want to know which one contains the initial condition. So specifically, which one contains t equals 3. And of course, 3 is bigger than 2. Don't think I'm telling you something you don't already know there. But it's got to be less than 3 pi over 2 because it's less than pi. And pi is itself smaller than 3 pi over 2. So it's in that interval between 2 and 3 pi over 2. So that's all we need to know. That tells us then that the interval of definition for this particular initial value problem is t greater than 2, but less than 3 pi over 2. And so we move on.